In the previous video, we went through and did a run using Insight 360. And if you go into Analyze, and we went in and we did our edit energy settings for our building, we set up our parameters for the building, and then we created an energy model that gave us this result that you see down here. And then we said generate an analytical model, and what it did is it went in and went back up to the cloud and generated that model. And then we after it was completed, we can go to optimize and look at the Insight site, and it will take us to this right here, which is the Insight site. And here's the completion of our run that wasn't complete earlier. If I go back to Insight, okay, so here are the last two runs I did, and this is that version 3 that we completed in the last video. And so if I go to that one, it'll take me back to where what you just saw just earlier. And just to kind of go over the format and what you've got here so that you would know what to analyze and kind of how to analyze things. It's loading a simple model of our site here and the components that were involved in the model, and I can take a look at that if you want to. There's a number of things you can do with the model. Personally, I don't find it a whole lot useful right now. Maybe in the future it will be, but right now I don't know. It just doesn't seem to be very useful to me. So with that in mind, then we're going to look at the results that we got. And so the first thing it's going to show you is, well, what it's going to show you, just to give you an oversight, is a whole series of blocks of different parameters that it ran to get the results, to get different results, and I kind of show you what that means. Okay, so here is the total result. We're at about $1.47. We're right below, barely meeting, but we're meeting the ASHRAE 90.1, which is the 2012 code requirements as far as energy loss, heat loss, and heat gain. Here's you can see the Architecture 2030. If you're familiar with the Architecture 2030 program being initiated by the AIA and the Department of Energy and several other people, this is where they would like for you to be by the year 2030 as far as the design of your building and the energy usage in it. So we've got a lot of work to do if we want to get there with our design, but let's take a look at some things. It normally orients the little blocks here, the little parameter runs, based on the impact that particular, the greater the impact, the higher it is. And you can see the first one is what we call plug load efficiency, and of course you should know, but you may not know, that means the energy that's consumed by everything that's plugged into it, and that's a value that you set. When we chose the conceptual office, it set that value itself. And if we go in here and look, I just clicked on that little circular thing, and you'll see a graph, and what it did is it ran the energy analysis as we had in our BIM model right here. Okay, and then it ran another energy analysis with an improvement to instead of 2.0, which is what we ran, which is the same as let's see, yeah, no, we had I think 1.5 or something like that, and then then it ran it for 1.6, and of course the plug load went up 2.0 watts per square foot and 2.6. So we can see if we're going to use more than our original 1.5 or 1.4, whatever it was. But if we go to 1.3 watts per square foot, we have a slight drop. You can see we saved 2 cents And then if we go to 1.0, of course, we're saving up to 16 cents. So we can make a tremendous impact on that $1.47 just by being more energy efficient about what we're using, what's using energy in our building. The efficiency of the computers and printers and Xerox machines and everything that we plug into a plug. And then, of course, if we get it down to 0.6, then we're talking about 35 cents. But that's in an office building, that might be pretty tough to do. So that's plug load and some things that we might be able to do, reducing the plug load. The next is light efficiency. Okay, so we're using right now, I'm trying to remember, I think 1 watt per square foot. That's 1.1 or maybe 0.9 watts per square foot. I think we're doing 0.9, which is pretty efficient. That's a pretty efficient light fixtures. And then, of course, if we go up, it's going to cost us more. This is numbers that we would have to add to this number. So you can see very little increase here makes a tremendous impact on the amount we would pay. And it would actually put us above the ASHRAE 90.1 if we did that. If we made, got the lighting down to 0.7, which would be easy to do by adding daylighting. Now remember, we didn't run any daylighting, so we could probably get this down just by making, having daylighting and turning these lights off. You may have the same lighting efficiency here, but if we don't use them, then our energy consumption per watts per square foot is going to improve. And then this is 0.3. Once again, that takes some really energy efficient lighting to do that, and incorporating with daylighting. Operating schedule. Okay, we set it to 12.6. If we drop that to 12.5, of course we make a significant impact. Okay, and if we up it to 12.7, we don't add a whole lot of energy to it compared to what we would save if we went to 5 days. And then of course here is 24/7. So just to give you an idea, we're just going to keep ourselves there. Right now I'd probably look at seeing if I could get down the plug load down to 1 watt per square foot, and if I could get the lighting down to 0.7, that would be great, because that's 10 cents right there, and then 16 cents, that's 26 cents off of this, which is what gets us down to 121. The next one here is HVAC, and this is just different improvements of HVAC system. We're using probably one of the least efficient HVAC systems around. Here's another one, next one up, that's even less efficient. But we could probably go in, go to a high efficiency heat pump or high efficiency package system. We probably don't want to use a package system on this particular building, but maybe a split package system like a VRF, a variable refrigerant flow. Okay, that's probably what I would do, is go to a variable refrigerant flow system, which would get us down in here, and that's another 20, as you can see, 20, 21, 23 cents. So if we just take 20 cents off of, once again, that earlier, then we're now down even further. I just clicked on that little graph, and let's go back. Okay, so now and then it's going to go through, and I'm not going to, in this video, I'm not going to go through every one of these, but I'll go through one set of windows. So they did an analysis, right, of the west windows, and the west windows are evidently, because they're the first on the list, are the most energy inefficient, have the greatest impact and the greatest potential for impact. So here it's just showing if we drop this down to 15%, we're going to be in a lot, we're going to just gather a 1 cent If we go to 0 windows on the west side, which we're not going to do because that's the view to Travis Park in this case, and we're not going to eliminate those windows. So that's not going to happen. So the only thing that we can probably do here is add overhangs and shade, do a much better job of shading, because we're not doing any shading at all in the previous run that we did, this run that we did here. Once again, here is, eastern walls, similar kind of almost format. Roof, we've got an R22 roof, which is, evidently not saving us a whole lot of energy, but it's saving us a little bit. But so, there's nothing to do really there. Let me scroll down just a little bit more now. And then daylighting, okay. We could introduce daylighting. I think we could even have greater impact if we had just daylighting controls. Here they're just talking about daylighting controls, not even optimizing the daylighting itself, just saying, hey, if we have adequate daylight, then dim the lights or turn them off, and as well as occupancy control. So you can see we can get another 8 cents there. I thought I looked at west. Oh, those were walls. I'm sorry. I called these windows, and they were not windows. They were walls. And we have pretty good insulation on that, and on the roof. Here's west-facing glass. Okay. Once again, not a whole lot of impact. We're using a pretty good glass, but we could drop it. They're saying go to triple low E. I would argue that no, we just need to get into a shading scheme and start shading those windows more effectively, and we'll drop that, 3 or 4 cents easily. Infiltration, we've got a pretty tight building, once again, but we could come in and do a little bit better, maybe. As you can see, if we get it any tighter, it's not going to make much difference. And the reason is because this is a commercial building and we have to bring in fresh air anyway. So it's leaky by the nature of that we have to provide fresh air. Once again, I'm just going to flip these over real quick so you can see them. Whoops. Window shades to the west. Wait, what was this? Windows to the east, window shades to the west. It's saying we can make some improvement. They're considering conventional window shading. If we go to a much more unconventional window shading, we could make better effect in that. But at least we could get 2 cents out of it just with conventional. Once again, eastern window, kind of similar kind of condition. Southern walls seem to have the least amount of impact. They're down here at the bottom. Window shades on the west, that's interior shades. Window shades on the east. I would go with, outside first, inside only if you have to, and I would couple them with the need for privacy. Window glass north, you can see, once again, I'm just going to flip these over. Window shades north, and as you can see, they don't have any impact whatsoever. And then PV panel efficiency, we've got pretty good efficiency, not really great. If you're doing Lubbock, this is going to be a lot better. Payback period, depending on how much we invest and over the time period, we really don't reduce much unless we go to a significant investment in PVs. Surface coverage, and this is surface coverage of the roof. So 60%, zero surface coverage, 60% coverage, 75% coverage, and 90% coverage. So you can see we could drop it 4 cents by providing some PV. So anyway, those are the parameters that it actually does parametrics on, and here's the result of that. So I want you to take a look at this, take each one of these graphs and analyze them. Either put a statement in here that says what considerations you should make, And in the next video, we'll talk a little bit more about some other tools inside the Insight plugin.